The next category in software engineering is requirements engineering. Quote here is from Fred Brooks of Mythical Man Month fame. This one actually comes from the paper of about 20 years ago on, what was it called? No Silver Bullet. Mm-hmm. He talked about essential complexity and accidental complexity and how the hardest part of any endeavor is deciding what to build and making those kinds of decisions. And I don't think a whole lot has changed in the interim, particularly with respect to requirements and the way they are expressed. So requirements engineering in general consists of activities like elicitation, analysis, specification, verification, and yes, we should probably include in the list validation, although I think it wasn't on the original list from the Dorfman paper. But these are the kinds of things that you should be doing already with respect to the engineering of requirements for a single system case. And some of the issues that you run into with requirements is that conceptually, at least, there are three different roles at play here. There's the requester, the source of the original requirement. There's the implementer or the developer that has to come up with a solution to that requirement. And there's the person who wrote the requirement, or there's the role of requirement writer. And they may be three different people and three different opportunities to point the finger when something goes wrong.
I've seen too many systems in the military particularly where you have a feature that's a person requested.
Yeah, and that's something that you will have to guard against. The one person requested feature that somehow ends up in the core asset base. Somebody pushed long enough and hard enough and made enough noise to get that one requirement addressed in the core asset base. By golly, this is going to be in the product line, whether or not anybody else needs it. So where's your process discipline? Where's your product line manager? Where's your careful analysis of what's really common and what's really variant? So the kinds of analysis of commonality and variability that you do in the understanding relevant domains practice area will play a role in what you do here for the requirements, because you're going to have to manage the requirements as both common and variant also. And we like to tell people that before you get into the details of requirements, you should at least understand what's common and variant at the feature level before you get into specific requirements. So it really paves the way for the kind of detailed requirements analysis. So you want to create a reusable requirements asset that captures the commonality of the requirements across the proposed set of products and the variance for a particular product. And you may allow the variation in terms of a parameterization, for example, in different levels of performance, or different levels of modifiability, scalability, whatever it is. But you are coming up with a reusable set of requirements that will cover the range of commonality and the range of variation across the products you intend to build. And then for product-specific requirements, the ones that aren't addressed within that reusable artifact are the ones that lead to the components that you develop outside of the ones already developed in the core asset base. But without that first segregation of what's common and variant, you won't have a good understanding of which requirements apply only to a specific product and which ones are really applicable across the entire range. And you can have the risk of polluting your core asset base with product-specific requirements and artifacts. So when you are eliciting requirements in a product line context, you have to know what are the common requirements and what are the likely variants, and over the foreseeable lifetime of the product line. And who knows what the foreseeable lifetime is? Well, presumably there are people in the organization who are doing these kinds of projections, who know about the lifetime in terms of the market potential for a particular product line or the mission need for a particular product line. You can't have the developers alone making those kinds of decisions. So even at the requirements analysis level, you still need to be cognizant of what's the target that we are shooting for here. What's common, what's variant across what set of products over what lifetime, and what kinds of future requirements do we need to think about incorporating into this, even if those requirements are not requirements of particular products we build right now. So planning for the future and being proactive about the business you're in and the features and requirements of the products to support that business. The analysis then builds on the understanding of relevant domains, commonality and variability analysis that you have already done or should have already done. And then you prepare a specification of the requirements that address what's common and what's variant and so on. And you also need to make sure that this is carefully managed in the sense that you really do understand the requirements that cut across the entire range of products and the ones that are specific to a particular product. And that can mean that you need to have people capable of abstracting from specific requirements to the more general essential requirement, particularly if you're looking at pre-existing products. Larry Constantine uses the example of what he calls essential use cases. So it's very often the case that you'll see requirements of the form, the user shall be able to log into the system by means of a username and password and get a response within whatever number of seconds. So that's not the true requirement. The password in particular, the username and password, is an implementation detail. The real requirement is authentication. Authentication could be by means of a username and password, but it could be by a fingerprint or a retinal scan. So if you, pardon? Or a common access card, yes. So if you are looking at requirements across an existing set of products, you need to be capable of abstracting those specific requirements into something that's more generalizable and more reusable, and treating these other lower level concerns as implementation details, or at least as details that don't factor into the commonality and variability analysis. So you need to have people capable of abstract reasoning and doing that kind of analysis. So the product line requirements will use the scope as input in the sense that any requirements that you are looking at should be over the proposed set of products that are within the scope. They will also help you validate the scope, because as you start looking into some of the details of the requirements, you may realize either, boy, we are really taking on more than we can handle here with the resources we have available. Or, conversely, if we looked at a few more additional systems and brought in the requirements for those in a common fashion, we could go after a nearby business area, or we could greatly expand the horizons of this product line. So your initial cut at the scope of the product line, what's in that set of products, may expand or may shrink depending on the outcome of things like the requirements analysis or the commonality and variability analysis. And the requirements that you collect are not just the functional requirements, they are also the quality attribute requirements that will drive the product line architecture. When you are looking at requirements across a range of products and creating reusable requirements for use across a range of products, you should also be thinking about, how are we going to test these? And can we come up with reusable test cases? So this is all part of the changing the mindset of the organization to a product line organization where everything is considered within the context of a set of products and not just a single product. So reusable requirements, reusable test cases, test plans, test data, all of these things are candidates for becoming assets in your product line. And then finally, when you're looking at the requirements for specific products to be delivered out of the product line, the schedule, the delivery schedule for particular products will determine which requirements to focus on first, and which subsets of features might be bundled as assets to support the products that are needed first. A colleague and I have been working in the area of what we call product line analysis, that brings in techniques from domain analysis, stakeholder view modeling, feature modeling, and use cases to make sure that the requirements of, and these are all basically, even at the feature level, you are still ultimately dealing with requirements, but making sure that you don't miss any requirements by looking solely at what the developers think are the requirements, for example. So stakeholder view modeling looks at who are the stakeholders in this product line and what's their view of the product line. So what's the security view of the product line, for example, and who are the stakeholders to represent that? So over and above the view that says, well, here are the functional requirements and here are the quality attributes, there are stakeholders, particularly external stakeholders like safety, certification agencies that have particular views on the product line. Do you have that kind of information? Do you have proxies within the organization for those stakeholders? Do you have people who are capable of understanding and incorporating those viewpoints into the analysis of features and requirements? Feature modeling is typically used by organizations that build feature-rich products and that understand the kinds of domain analysis expertise that go along with feature modeling. But if you are proposing to create some features in the product that are not in any current product and you don't fully understand the implications of those features, a good technique is use case modeling or change case modeling to understand, well, we're not quite sure what this feature would be, but we've heard that the competition is planning to produce a product in this area, so what does that mean for us? Can we explore this by means of some simple use cases? And change case modeling is all about, if we put this product in the marketplace, what are the likely changes that people are going to request? So they like our product, but can you change this, this, and this? Can you change the user interface? Can you increase the number of users? So try to anticipate what kinds of changes are likely to be requested of your products and do some modeling of those changes and make sure that you don't preclude those kinds of changes when you come around to designing your architecture. So this is all about being proactive and making the kinds of decisions that will not lock you out of particular markets at the earliest point when it's the cheapest to do so. The biggest risk in this is not distinguishing between what's common and what's variant, not doing a good job of really understanding the true level of commonality across the range of products and the range of variability that goes along with that. Beyond that, then, you have things like either you're trying to create assets that are much too general or not general enough. So you've tried to make this asset reasonably parameterizable, but over the range of products, it just won't fly because you haven't done enough of the analysis to make sure that it has the right level of variability. Putting in the wrong variation points because of miscommunications or lack of stakeholder input, for example. So your stakeholders wanted variation with respect to product customizability, and you interpreted that as, okay, we'll give them a flexible user interface and they can choose the colors of the boxes on the screen. So you've provided variability, it's just the wrong kind of variability. And in requirements, if people think about non-functional requirements or quality attributes at all, the one they think of first is performance. But there are many other things besides performance. There are all those ilities, modifiability, scalability. They're not direct functional requirements, but you need to address those because, as they say in the world of real-time systems, the right result late is wrong. So it's not just the correctness of the number that's produced, it's when it was produced is an element of the correctness. So there are quality attributes in addition to, we prefer to call them quality attributes rather than non-functional requirements, because non-functional requirements sounds as though they don't do anything. And these are some of the references in this area. The second one there, Chastec, that's the one on the product line analysis work that we have done here at the SEI. And Somerville is Somerville's book on software engineering in general, but he's the one who has worked on this whole area of stakeholder viewpoint law. And there's a lot of good general guidance in there about requirements engineering in general, not specific to product lines. Dare I ask how your current requirements engineering process is going and whether or not it could be tailored for a product line context? You know, this whole idea of identifying common versus variant requirements, would that be a challenge? A big challenge.
Each business unit capture requirements. So each business unit offer their requirements, not thinking enterprise-wide what that will help other business units.
Right, so the business units aren't doing that, but is there a role that sits above the business units that is thinking about that? And if there isn't, then yes, that's a challenge. So this gets back to the role of product line champion and how serious the organization is about becoming a product line organization.
Where I see the challenges, at least within the military, the areas that lend itself to product lines, like the aircraft, etc., those are funded as separate little tribes. And
Yes.
those requirements the number one priority. And inducing requirements on somebody else that didn't fund it.
Yeah. Yeah. Funding model. Who pays
For it?
is potentially a big constraint on what you can do. Right, next in this category is architecture definition. And as Paul Clements likes to say, every system has an architecture, whether you know it or not. And it would be nice if you knew it. And it would also be nice if you shared it with the people who are expected to create components that conform to this architecture. And we have seen cases where architects have been very reluctant to divulge their wonderful designs for whatever reason.
Job security.
So, well, there's that too. In fact, I forgot to mention that when we were talking about understanding relevant domains. The area of resistance that you may find in understanding relevant domains is if I'm the domain expert and you're coming to me and you tell me you want to create a reusable representation of my knowledge that can be shared across the organization. Well, why should I play ball in this? I want to be the indispensable expert. If I share that knowledge, it's gone, and then it's bye-bye me. So I see it as job security not to play ball in this product line effort. So now what's your product line champion going to do? This would all work very well if there weren't any people involved. But once you get people involved, things start to fall apart. So architecture definition, again, it's having the product line architect. Architecture is one of your early points where you can screw up an entire line of products as opposed to a single product. So you need to determine whether or not the architecture that you create is suitable for the purposes for which it was intended. And an architecture is neither right nor wrong in and of itself. So, is an N-tier architecture better than a Blackboard architecture, better than a client-servant architecture? Well, it depends. It depends on what it's being built for. It depends on the quality attributes it's supposed to address. So you need to understand the driving quality attributes that will determine what the architecture looks like, and you need to evaluate the architecture with respect to those quality attributes. And quality attributes are things like performance, modifiability, reliability, scalability, security, and so on. And you need to have at least a shared understanding of what those abilities and qualities mean across the team that's going to create the product line. You don't necessarily have to have the perfect textbook definition of what each of these is. In fact, there probably isn't a textbook definition of many of these. I know a lot of work has been done in the area of performance, reliability, and security, but for the most part, what you are striving for is an understanding that's shared across the team that's going to be affected by these. So you need to understand which requirements have a significant effect on the architecture. And you'll start getting an idea of that when you look at the understanding of relevant domains, you look at the scope, you look at the proposed range of products, the proposed variants to address different market niches, and how one product differs from another, because the difference, essentially all products in a product line are variants of some common baseline. And so what's common and what's variant, that has a major effect on the architecture. So a lot of the preliminary work that you should have done in your understanding of relevant domains, whether or not you use a formal domain analysis method, and the work that you've done in your requirements analysis, both functional and quality attributes, will play a role in defining the architecture. So you need to make sure you have identified points of variation, the important architectural structures, and you need to document it in terms of what is now called the multi-view approach to software architecture. There's no one representation of the architecture that will allow you to reason about all of the desirable properties of the architecture. There's one view that looks at the static structure in terms of modules. There's another view that looks at the runtime structure in terms of communicating processes. And so you need to create, the architect needs to create as many views as necessary to reason about the particular properties of the architecture. And you, the architect, need to make sure that the architecture is communicated to the people who are expected to conform to it. Several years ago, we conducted an architecture evaluation using the SEI ATAM method, Architecture Trade-off Analysis method. I wasn't part of this, but I heard about it afterwards. We did it for a large financial organization here in the US, and the ostensible purpose of an architecture evaluation is to determine whether or not the proposed architecture is any good. The real reason for this one was to get the architect fired. Of course, we weren't told that going in. The problem was this architect simply would not communicate the architecture to other people. It was, I am the architect. I will listen to you guys as stakeholders, but I'm the ultimate decision authority here, so I don't need to share this with you. I'll just take all these inputs. I have this architecture up here. When I design this system, it's going to be great. You just worry about creating components that conform to it. This guy would not listen to stakeholders, so the company decided we're going to basically expose this problem in a public forum where we have a third-party independent evaluator, the SEI. We have stakeholders from across the organization, and it became abundantly clear that this guy was not listening to the stakeholders and not addressing their concerns. And so he's no longer the architect. That was an unorthodox use of ATAM and not something for which it was intended. So generally what you need to do is evaluate the architecture with respect to the quality attributes that were identified for it in the earlier analysis, and make sure that you have a documented representation of the architecture. So the product line architecture then is something that will apply to all members of the product line. Each product architecture is an instantiation of the product line architecture. So the product line architecture has to have those variation mechanisms built into it for the specific product variants that are envisioned for the product line. And your variation mechanisms, and the SEI has done a fair bit of work in this and published some technical reports on this. Your variation mechanisms, and I'll show you some in a minute, but the variation mechanisms are essentially how you distinguish one product from another, or how you build one product from another. So they are the embodiment of the differences from the baseline for specific customers and users. And you also need to choose the kinds of variation mechanisms that support your production strategy. So for example, if your strategy is to reuse as much as you can from existing products, you are probably going to wrap several components from existing products so that they can be incorporated into the architecture. And your production mechanism and your variation mechanisms must allow for basically this swap in, swap out of components across the product line, which is different from a variation mechanism based solely on compile time if-defs, for example. So all of these things play a role in determining what the architecture is going to look like and how it's going to support the way you intend to build that set of products. And it's going to support the integration of the pieces of those products as well, because in a product line with a large number of products, you're going to spend a lot of time integrating the various components for the different pieces or the different products that you intend to build. So you'd better make sure that your variation mechanism supports efficient integration and has an appropriate set of tools to go along with it. So the common requirements, as you might expect, will tend to map to the fixed portion of the architecture, and then the product-specific requirements to the variant portions of the architecture. So again, tying this all to the initial scope, the initial domain analysis, the initial requirements analysis, all of that early work starts to show up here in the design of the architecture. And if you haven't done that early work, what can happen is something that I've seen happen on a couple of our architecture evaluations, is that the architecture evaluation is less about evaluating the architecture than it is about gathering up all those requirements that were missed on the first go-around. There is some help for this in the form of, first of all, the SEI Quality Attribute Workshop, a workshop aimed at helping you elicit some of the likely quality attributes of your architecture before an architecture actually exists. You should look at your production strategy also and determine what influence that has on your architecture. So is the strategy to create a set of components supported by an architecture for a set of products that doesn't yet exist, in which case you have much more freedom than if you are trying to incorporate an existing set of artifacts from an existing line of products. And you need to think about how is the architecture going to handle the variants of the products that are proposed for my product line, and what kind of mechanisms are appropriate there. Designing the architecture, then, there is a lot more information available than when pioneers like Celsius Tech started out. So there's a lot more information available in the form of processes like the rational unified processes, an architecture-centric way of doing things. There's a lot of good work being done in the patterns movement, both in the design patterns and the architecture patterns movement. In fact, are any of you familiar with the patterns movement? At least, have you heard of the Gang of Four book or the Bushman book for software architecture? Okay, good. So there has been an attempt to codify reusable expertise in the form of catalogs of designs, architectural patterns, and design patterns. And so with all that's available now, there's basically no excuse for not getting it right. And so that's why I said earlier that the first step for an organization to become a product line organization is to become an architecture-centric organization. So you have a lot more information available now. There are also things like SOA and aspect-oriented software development that are very much in line with product line thinking. How many people here have heard of aspect-oriented programming or aspect-oriented? Oh, good, good. That's always reassuring. So remember I said earlier about how we assume that you're familiar with modern software engineering concepts. So the kinds of things that people are dealing with in aspect-oriented programming, and in fact its evolution into aspect-oriented software development, are the cross-cutting concerns that are like the quality attributes that can't be isolated to a single component. There is no reliability component, but reliability as a quality attribute cuts across maybe all of the components in a system. And so coding them as aspects is a nice way of incorporating that kind of thinking into a product line development effort. Many different kinds of variation mechanisms, ranging from the large-grained approach of omitting or having particular kinds of components or component substitution, down to the humble if-def, compile time variation. So various kinds of variation mechanisms at various levels of sophistication. Your product line architect should have a range of techniques that he or she can apply to the creation of the architecture. Documenting the architecture, then, UML has more support than it used to have for documenting an architecture, and the whole approach of documenting the architecture in multiple views had its roots in Philippe Cruchton's 4+1 view of architecture paper, where you have a number of different views, and the +1 is a set of scenarios tying the views together. The SEI work on documenting software architectures is basically an extension of that. You come up with as many views as the architect deems necessary to reason about properties of the architecture, and document the architecture in a set of views and in guidance that describes how those views relate to each other. In fact, one of our customers, not the guy who got fired, but he didn't become a customer of ours, but one of our current customers claims to have a software architecture that is going to be used on a production effort. The problem is he hasn't shared it with anyone, and people are already developing components. And when we asked him, well, can we at least, and he keeps telling us, trust me, it's all in here. When we asked him, can we at least get a draft of the architecture? He said, sure. And he sent us the draft. And he's been to the SEI Documenting Software Architectures course, so he has this lovely template with placeholders for all of these views and a front-end section that describes how the views are going to work together, but there's no content. Meantime, components are being developed and there's a product ready to go, and so they are conforming to I don't know what. So if you don't do a good job of creating a product line architecture, then you won't be able to wire the components together to create the products in it. Not only that, but they probably won't meet the goals that were established for them, particularly the quality goals. It might also lock you out of being able to produce products that are supposed to be within the scope. The architecture itself, an unsuitable architecture, can be characterized by things like you don't have the right kind of parameterization associated with the components in the architecture, you don't have good specifications to begin with, or you don't do a good job of designing the architectural elements. So again, going back to what I said about you need to be an architecture-centric organization to be successful in software product lines. And then you have other risks there, like you don't have the right level of specificity with respect to either product-specific stuff or product line-wide concerns. And dragging along a lot of inter-element dependencies as you move from one product to the next is really not an appropriate modularization of the concepts of commonality and variability. The biggest risk in my mind, though, is not having a skilled architect in the first place. So your product line architect had really better know what he or she is doing. I think that is the single biggest risk in all of this. After that, these others are pretty much secondary. Lack of sound input means either you didn't listen to all of your stakeholders, or you weren't able to distinguish when the stakeholders were bullshitting you and putting their particular concerns over the needs of the rest of the product line, which is why in our architecture evaluation we call it the architecture trade-off analysis method, because the architecture can't simultaneously satisfy the concerns of all of the stakeholders. So some trade-offs and prioritizations need to be made. Poor communication, if the architect doesn't share the architecture with the developers. Lack of supportive management and culture. If your organization is not ready to become an architecture-centric organization, or doesn't appreciate the benefits of a software architecture, or why you would even need to think in terms of the architecture of a product as opposed to the lower level design, then it's going to be hard to move from that into a product line organization. Doing architecture in a vacuum. The software architecture exists within the context of the overall system architecture. And so there are system engineers that provide important contextual information to your software engineers. Poor tools. Probably the number one architecture documentation tool today is PowerPoint. Yes. Some of our customers have moved beyond PowerPoint and are using things like System Architect, or in the previous life, Rational Rows. So it would be nice to have some level of support for the kinds of diagrams and interconnections and some semantic linkages between these artifacts, and something that will allow you to create. You don't want a tool that locks you into having a complete design. You need to be able to have a tool that supports incomplete artifacts, but will also allow you to check whether or not all the boxes have been filled in and all the semantic interconnections are in place. And finally, poor timing refers to freezing the architecture either too early or too late. Too early in the sense of you don't have enough of the required input from the stakeholders. Too late in the sense of you're into component development, or worse still, product development, and now you decide this is what the architecture is going to be, but we already have a product out there that doesn't conform to what we're planning on freezing on. And these are some of the references in this area.